Question number 3. In a photoelectric experiment, a light of wavelength 400 nanometer is incident on a metal surface which has a work function of 2 electron volts. So this one, you have to calculate the threshold frequency, the stopping voltage, the energy for a light of wavelength 700 nanometer, and determine what will happen to the photoelectron on this metal. Okay, what will happen is basically it's asking whether will it come out of the surface or will it stay in the surface, ataupun will it come out of the surface but not moving. So basically it stays on the surface. Okay, so question 1, threshold frequency can be calculated using this equation of work function. So rearrange for threshold frequency, you should get 4.83 times 10 to the power 14 hertz. Okay, and then question B, the stopping voltage is we are going to use the Einstein photoelectric equation, which is equal to EVS equal to, I'm sorry, I'm not sure, is this the photoelectric Einstein photoelectric equation? Yes, it is the Einstein photoelectric equation because that is this one. Kan? Oh, I think I did something. Allah, I've posted our lecture note. But make sure you've changed this into HF instead of H small f. Okay? Alright. Let me just double check to make sure I'm using the right. Yes, okay. So this is the Einstein photoelectric equation, which is this one lah. Basically, the kinetic energy can also be written as EVS lah. Okay, E, which is the charge of the electron, and then the stopping voltage, the product of them two. Okay, alright, now this is gonna be equal to Hc over lambda minus the work function. Okay, so this is, if I were to write this, it's actually maximum kinetic. Is it the maximum kinetic energy? Yes, it is the maximum kinetic energy, equal to the energy minus the work function. This is basically the Einstein photoelectric equation. This one is expanded punya version. Okay, I just don't want you to get confused. Okay, so calculate that. You will then get 1.77 times 10 negative 19 joule. Okay, so that is the EVS, and then calculate full stopping voltage. You should get 1.11 volt lah. All right. Okay, and then question C, this one we are gonna use the energy punya equation, which is E equal to Hc over lambda, and then calculate that. You should get the energy to be equal to 2.84 times 10 negative 19 joule. Okay, convert that into electron volt. Wait. Sorry, let me just think about this first. Okay, so convert this into electron volt because we need to compare it with the work function. Okay, because the work function is given in electron volt, so that's why I am comparing it in electron volt lah. Okay, so E in electron volt is going to be 1.78 electron volt. Remember, that is just dividing with the charge of electron. Okay, so what would happen with the electron if a photon is incident on the metal? As we can see, the energy is less than the work function, which is 1.78 less than 2. Okay, so this situation, when the energy is less than the work function, no photoelectrons malas lah mau tulis, will be emitted. Okay, so remember the 3 cases that I've included in this notes. Remember, if the energy is less than the work function, there won't be any electron being emitted. Okay, all right, so that is our solution number 3, the solution for number 3.